Hello everyone, welcome to my YouTube channel. My name is Evidence, and in today's video I am going to show you how to build a random forest classifier model. So let's dive in. So before I started this video, I went ahead and cleaned up my data and split my data into training and test data sets. So if you need to clean up your data or encode your data, make sure you do all that stuff before you get to the modeling part. In a different video, I show you how to clean up data, how to encode your data, and all that stuff. So let's go ahead and get a preview of the data set. So this data set is trying to predict wine quality. These are the features for predicting wine quality. And this is a sample of the training data of the training target. So our target is wine quality in this situation. And there are 7 different categories. So this is a multi-class classification problem. So now that we've gotten a preview of the data, let's go ahead and import the necessary libraries. So from sklearn.ensemble, import random forest classifier. After importing it, we are going to instantiate the classifier. So let's just call it RFC is equal to random forest classifier. We are just gonna use all the default parameters. So random states just keeps things consistent so that next time in the future when I run this code cell, I'll get like the exact same result. And if you run this code cell, you get the exact same result. So it's a matter of consistency. That's why I always put random states here. And we are going to use all the default parameters. So if you look at the random state, if you look at the random forest classifier, it has many parameters for you to choose from. But for this example tutorial, we'll just use the default parameter. So now that we've instantiated it, we'll go ahead and fit our model. So this is the random forest classifier documentation. And if you come here, these are the parameters for you to choose from. It's a lot. And these are the attributes. Basically, attributes are things that you have access to after you have used this classifier to fit and predict your data set. After running this classifier through your data set, you have access to these informations. If you scroll down a little bit, you can see the different method here. There's the fit method, there's the predict method, and there's the score method. And then there's other method available. So in this video, we mostly use fit method, the predict method, and the scoring method. But I just wanted to show you where these things are coming from. So when I start doing .fit, .predict, you will know what it means. So we'll do RFC .fit, and we provide our training data and our training target. So now that we have fit our model to our data frame, the next thing is to use our model to make predictions. All right. So to do that, you simply do, let's call this widespread RFC. Just to differentiate it, we do rfc.predict. And in this case, we provide the S-test. So we have used our model to get a prediction. And we can get a preview of what our predictions are. That's if you wanted to look at the raw numbers. Okay. So now that you have fit your model through your data frame, you have used your model to create a prediction. How do you actually know that your model is accurate? How do you evaluate the performance of your model? If you're doing a regression problem, you use regression matrix to evaluate your model. If you're doing a classification problem, you use a classification metric to evaluate your problem. In classification problems, one of the most commonly used metrics is accuracy score. Okay, so we are going to use accuracy score right now to evaluate if this model is good or not, like evaluate the performance of this model. And I'm gonna show you two ways to get accuracy score. So one of the ways to get accuracy score is to use the built-in accuracy method from the model. And to do that is very simple. You simply do something like rfc.score. So now we are using the score method. And in this case, you provide your S test and then you provide your Y test. So if you look at the scoring method, you provide your X and the Y. And if we go ahead and run this, it gives us an accuracy score of 66%. So this is actually good, and I'm gonna show you why it's good. It's like better than what we had before. The second way to get accuracy score is by using Sklearn accuracy score metric. All right, so they'll give you the exact same result, but I just wanted to show you different ways of doing the same thing. So you do from sklearn.metrics, import accuracy score. All right, and to get the accuracy score using this method, you do accuracy score, and then you provide your true value and then your predicted value. Okay, and then if you run this, did I just do Y true? This is Y test. All right, so if you run this, it gives you the exact same score. All right, so if you're using the built-in scoring method, you provide the S test and then you provide your Y test. But if you're using the accuracy score from Sklearn metrics, you provide your true value, in this case the Y test, and then you provide your predicted values, in this case your Y-pred RFC, which is the predictions from here. Okay, so that's two different ways to measure, to get the accuracy score from a random forest classifier model. So how do you actually know if this accuracy score is good, bad, or an improvement? Well, you compare it to your baseline model, right? In a different video, I show you how to get a baseline for a classification problem and how to get a baseline for a regression problem. So after you get your score like this, you want to compare it to the scores that you got from different models and the scores you got from your baseline. So let me go ahead and get that information. So I went ahead and grabbed the score from my decision tree classifier. In a previous video, I showed you how to build a decision tree classifier model. Then I'm gonna get the baseline accuracy score too. So this, we are going to be comparing 3 accuracy scores. All right, there we go. That looks a lot better. So basically, right, our baseline accuracy score was 45%. The accuracy score from our decision tree model was 59%. And the accuracy score from our random forest classifier model is 66%. Okay, so the random forest classifier model is a much better model than the decision tree classifier model and or our baseline. So that's really good. But accuracy score is just one metric for evaluating your random forest classifier model. So now that you have evaluated your model, how do you explain your model, right? Which features do you point fingers to and be like, this feature, or this feature is mostly responsible for being able to predict the wine quality? Which features are most important for predicting the wine quality? Okay, you can get that information using something called the feature importances. And what does this feature importances numbers mean? In the next video, I am going to show you how to explain your random forest classifier model. I'm going to show you a couple of techniques for explaining your random forest classifier model and also other ways to evaluate your random forest classifier model, and then I'm going to talk about what the future importances in a random forest classifier model means. That's gonna be on the next video, so make sure you subscribe to the channel so you get notified of that video. But to get access to this notebook that I use in today's video, you can just go to machinelearningeducation.com. This is a platform I created to give you access to my notebooks and other resources. So if you click on this, you will land on this page. And through here, you will get access to my data science tutorial notebooks. So I create a lot of YouTube videos and a lot of blogs, and I just found it easier and more straightforward to take all that notebook and put it under one platform, so you have easy access to it whenever you need it. And I also have my videos in here, my blog posts in here, and I have other resources in here. And that website again is machinelearningeducation.com/free. And you can also visit me online at evidencen.com. So this is my primary website where I create data science blogs. And as time goes by, I'm going to create more data science blogs, and I'm going to add it here. And this is evidencen.com. And if you are here, you can also get to the free data science resources by clicking on that button, and you'll be able to get here. If you like this video, please give it a thumbs up and subscribe to the channel. If you made it this far in this video but you didn't like it, please give it a double thumbs down and still subscribe to the channel. Thank you for watching, and I'll talk to you on the next one. Bye.